Hello Year 10. Last week we talked about rates of reaction. Okay, so we talked about how we would measure the rate of a reaction by doing this kind of experiment, where we measure the amount of gas given off, or we might have measured the amount of mass lost. So this is the mass of the gas lost, and this is the volume of the gas lost. And we thought about, how the rate might change as the reaction happens. So it will start off very quick, and then it will slow down, and eventually when the reaction finishes, there won't be any change in the volume of the gas given off. So this week, what we're going to do is we're going to think very carefully about what factors affect the rate of a reaction. Now, again, like I mentioned last week, you can read about this in the textbook. It's on pages 146 to 155, so we're still chapter 5.1, right? So you can supplement the video with reading from the textbook, all right? But I will go through the core points. Okay, so we're going to learn about what factors affect the rate of a reaction. But before we do that, we need to really understand how reactions happen. So, so if I write out an equation such as H2, so hydrogen gas, plus I2, that's iodine gas, and I get 2HI gas. Now you should all be fairly happy with that reaction as it is written there. So the idea is that I have this molecule, this covalently bonded molecule, this covalently bonded molecule, and they react together and they produce a new covalently bonded molecule. And it's balanced. There's two hydrogens here, there's two hydrogens here, there's two iodines here, there's two iodines here. Okay. Now you don't need to memorize this equation or anything like that. This is just an example so you can see what's happening. Now, how does this reaction? Sorry, I'll just draw that as that arrow. How does this reaction actually happen? Well, if you imagine what I've got is a box. All right. And in my box, I've got molecules of hydrogen. Like this. Okay, these are all molecules of hydrogen. Now I've also in there, I've got molecules of iodine. Now iodine's a bigger molecule because iodine atoms are much bigger than hydrogen atoms. Hydrogen atoms are tiny. Okay, so these are my molecules of iodine. Now, what's happening is that these molecules are flying around inside the box there. They're moving because they're gases. All right. So how do they end up as this in my products box over here? How do I end up with a box full of this HI? All right, so you see the atoms have rearranged themselves, and now what I've got is, it's not to scale, and there's not the right numbers of each one, but don't worry too much about that. But you can see I start here with hydrogen molecules and iodine molecules, and I end up with HI molecules. How does that happen? Well, unsurprisingly, because they're flying around, what happens is that a hydrogen molecule and an iodine molecule will eventually fly into each other. Okay, that one's moving in that direction, this one's moving in this direction, and eventually they're going to fly into each other. And what we say is that we have a particle collision. All right, so that's what happens. These particles collide with each other. So you can imagine if I have my hydrogen molecule and my iodine molecule, all right, if they are flying around and this happens, they go past each other, there's not going to be a reaction. But if they hit each other, then there might be a reaction. So what we can say is, down here, I'm going to write reactions only happen if, number one, particles collide with each other. So that is my first requirement for a reaction. The particles have to collide with each other. Okay, if this hydrogen molecule's over here flying around and this one's over here flying around, they're not going to react. They need to hit each other. Okay, but that's my first requirement. Now there is a second requirement. So let's imagine that these two molecules are flying around. Imagine the screen now as a box. Okay, so they're moving around inside the box and they collide with each other like this. Did you hear it? Okay. Do you think this collision is going to result in a reaction? No. Okay, because it's too slow. They've got not enough energy. There's not very much energy there. So what's going to happen is they're just going to bounce off each other because they're not going fast enough. All right, they don't have enough energy. Now, what do we think if the particles collide like this? Okay, see how much energy there was there? So it's a much louder sound when they hit each other. Right, that's because they've got more energy. So if they've got more energy, then the particles are more likely to react. Okay, so we say that the reaction will only happen if the particles collide with each other and, number two, the colliding particles have enough energy to react. All right. Now, how much energy do they need to react? That's the important question. All right. Well, this energy, the energy required for a reaction to happen, has got a special name that you know. And it is, what is it? Say it now. Okay. I'm sure you all said it. It is the activation energy. Okay. So, if the particles have the activation energy, then they will react. If they do not have the activation energy, then they will not react. So, what we have is, if we relate this now to the rate, okay, well, the particles colliding with each other, okay, we can talk about the frequency of collisions. Okay, and if there could be more collisions or there could be fewer collisions. All right, and then in terms of the colliding particles have to have enough energy to react, we can say something like the proportion of collisions which are successful. All right, so you can imagine if the colliding particles have got lots and lots and lots of energy, then there will be a greater proportion of collisions which are successful. And if the particles have not got very much energy, then there will be a smaller proportion of collisions which are successful. Okay. Now, what we're going to do in the next part is we're going to take these two ideas, the idea of the frequency of collisions that happen, and the proportion of those collisions which are successful, and we're going to combine those two ideas into something called the frequency of successful collisions. Okay, and the frequency of successful collisions, that is what determines the rate of reaction. So, if we have a high frequency of collisions which are successful, we will have a fast rate. Okay, and remember, a collision is successful if it has enough energy. Now, if we have a low frequency of successful collisions, that will mean you've got a slow rate. Now, a low frequency of successful collisions might be because not many of the collisions are successful, or it might be because there aren't many collisions. All right, so we need to think about, when we're thinking about this, we've got these two ideas. How many collisions are there? how many of those collisions are successful. And together, that tells us the frequency of successful collisions, which tells us the rate of a reaction. Okay, and we'll go through all the different factors and you'll see how this works. So there are 4 things which affect the rate of a reaction. All right, so 4 things affect the rate of a reaction. And they are, number 1, temperature. Obviously, okay, so that should be fairly obvious to you. If you make something hotter, it will react faster. If you make something colder, it will react slower. Number 2, the concentration, all right, or pressure. So we're going to deal with these. When we come to those, I'll tell you how concentration and pressure are really very similar things, okay. Number 3 is going to be particle size. And particle size we can also think of in terms of surface area. And number 4 is the presence of a catalyst. Okay, so all right, so I'm gonna that's a nice, just very condensed introduction to collision theory. This idea that in order for a reaction to happen, there needs to be a collision of particles, and those particles have to have enough energy. So that's what I mean when I talk about collision theory. All right, so now we understand how reactions happen. We're going to move on to discussing these 4 factors that affect the rate in the next video.